So in this problem, we have an arithmetic mean inserted between two numbers, and also two geometric means represented by g1 and g2 that are inserted between those two numbers. So we need to show that the following expression is true. So let's begin. So we will first have to specify the numbers. So let the two numbers be a and b. It's given here in the problem that one arithmetic mean is inserted between a and b. So let's represent it by the letter a. So a, and b, these numbers are in arithmetic progression, which would mean that a must be equals to a plus b divided by 2. Or simply 2a will be equals to a plus b. So let's label this as equation number 1. And also it's given that we have two geometric means g1 and g2 inserted between a and b. So our first term will be a followed by g1. Then we have g2 and the last term will be b. So these four numbers are in geometric progression. So since they are in geometric progression, we can define the common ratio. So the common ratio is defined as the last term divided by the first term raised to the power of 1 over n plus 1. So here n represents the total number of arithmetic mean that are inserted between a and b. So that value is equals to 2. So that means our r value is equals to b over a whole raised to the power of 1 over 3. So now that we have the common ratio, we can obtain the value of g1 and g2. To obtain the value of g1, all we have to do is take the previous term a and multiply it to the common ratio r. So that means b over a raised to the power of 1/3. So this is going to give us a value a raised to the power of 2/3 multiplied to b raised to the power of 1/3. Then we can also obtain the second geometric mean g2. All we have to do is take the previous term, which is this a raised to the power of 2/3 times b raised to the power of 1/3 and multiply it with the common ratio b over a times 1 raised to the power of 3, and this is going to give us a value a raised to the power of 1/3 times b raised to the power of 2/3. Now let's start with the proof. So we'll start from the left hand side of a given expression. So here we have g1 squared. So we will square g1, so that will give us a raised to the power of 2/3 times b raised to the power of 1/3 whole squared divided by g2, because g2 is a raised to the power of 1/3 multiplied to b raised to the power of 2/3. This will be added to g2 squared. So g2 squared will be a raised to the power of 1/3 times b raised to the power of 2/3 whole squared divided by g1. So our g1 value is a raised to the power of 2/3 times b raised to the power of 1/3. Right. So let's further simplify. So this is going to give us a raised to the power of 4/3 multiplied to b raised to the power of 2/3 divided by a raised to the power of 1/3 times b raised to the power of 2/3 plus a raised to the power of 2/3 multiplied to b raised to the power of 4/3 divided by a raised to the power of 2/3 times b raised to the power of 1/3. So b raised to the power of 2/3 will get cancelled and a raised to the power of 2/3 will get cancelled. This leaves us with a raised to the power of 4 over 3 minus 1 over 3 plus b raised to the power of 4 over 3 minus 1 over 3, which will be a plus b, and a plus b, we have already mentioned that this is equals to 2 times the arithmetic mean between a and b. So we have obtained the expression on the right hand side, hence proved.